When something is slow or broken in production, you need to see it, not guess at it. And a wall of log lines doesn't show you the shape of a request, it shows you fragments. Observability is 3 signals together: traces, metrics, and logs, all correlated, so one request becomes one readable story. Trellis wires this up with OpenTelemetry, and it gives you spans for your handlers and your value objects that you never had to write. Let me show you. Observability in a Trellis service is one OpenTelemetry setup, and it gives you all 3 signals exported over a single open protocol, OTLP. On the tracing side, 3 lines do the heavy lifting. AddAspNetCoreInstrumentation traces the HTTP edge, the incoming request. AddSource Trellis.Mediator emits a span for every command and query that flows through the mediator. And AddPrimitiveValueObjectInstrumentation adds a span every time a value object is created, every TryCreate. On the metrics side, AddService-Level-Indicator-Instrumentation emits your latency metric, which is the whole of next episode. Wire it once, and every layer reports itself. And here's the payoff: a single post as one trace. Read it top to bottom. The request hits post/projects. Inside it, the CreateProjectCommand handler runs. Inside that, each value object validates itself: ProjectName.TryCreate, DueDate.TryCreate, and then SaveChanges writes to the database. That's the clean waterfall we keep coming back to: an endpoint, a command, a value object. And because every span carries its own duration, you can see exactly where the time went. Here, it's the database, not your logic. No guessing, no scattering print statements. The structure of your code is the structure of the trace. Now, a trace is just one of 3 signals, and the real power is that they're correlated. A trace shows the path of a single request, the spans you just saw. A metric shows rates and durations in aggregate, like that latency histogram, which is next episode. And a log is a structured record of something that happened. And crucially, it carries the same trace ID as the request it belongs to. So when a metric spikes, you jump to a slow trace. And from a span, you jump to the exact logs for that request. And all of it speaks OTLP. So you point it at whatever backend you like: the Aspire dashboard in development, Grafana, or Honeycomb in production. The framework doesn't lock you in. So why does this matter? 3 reasons. 1. You see the shape of a request, not a wall of disconnected log lines. When something is slow, the trace shows you which span ate the time, instantly. 2. The handler spans and the value object spans come free. You didn't write a single line of instrumentation in a handler. Trellis emits them because the mediator and the value objects are framework concerns. And 3. It's all OTLP, the open standard, so you're vendor neutral. Point it at the Aspire dashboard today, switch to a hosted backend tomorrow, and change nothing in your code. Observability that's on by default, and yours to take anywhere. So that's observability the Trellis way. 1 OpenTelemetry setup, 3 correlated signals, traces, metrics, and logs, and spans for your handlers and value objects that you never had to write. A single request reads top to bottom like a sentence, and all of it ships over OTLP to any backend you choose. Next time, we zoom in on the one metric that matters most for reliability: the service level indicator, the latency measurement that drives your SLOs. Subscribe, and I'll see you there.